We're going to break the silence the auto industry has kept for decades. There's a world of technical knowledge that the big brands and dealerships prefer to keep hidden, not because it's dangerous to you, but because it's dangerous to their business model. Every time you take your vehicle to the official shop, you're feeding a machine designed to extract the maximum amount of money from your pocket. They tell you certain procedures are complex, that they require specialized equipment, that only certified technicians can perform certain adjustments. But the truth is very different. For over 30 years, working under the hood of thousands of vehicles, I've learned something fundamental. Your car is much more capable than they've led you to believe. The limitations aren't in the machine, they're in the information they've denied you. Manufacturers configure your vehicles with conservative settings, prioritizing comfort and the longevity of cheap components over true performance. They sell you power and capability, but they deliver it tamed, numbed, chained by software parameters designed to protect their warranties, not your driving experience. Today, I'm going to share 10 procedures with you that the industry considers illegal, not because they violate any real law, but because they violate the unwritten code of dependency they want you to maintain with them. These are the tricks that will transform your used or pre-owned vehicle into a more powerful, efficient, and reliable machine. They are adjustments and deep maintenance that veteran mechanics know but rarely share outside the shop. If you've come here looking for real answers, you found the right place. Before we continue, I need to ask you for something. If you find this information valuable, if you believe it deserves to be shared with other drivers who are tired of being treated like mere consumers, press that like button until it turns blue. Then, subscribe to this channel and activate the notification bell. What you are about to learn could save you thousands of dollars and years of frustration. Don't let this knowledge get lost in the algorithm. Share it, save it, apply it. Now, let's get to work. Trick number 1. The complete reset of your vehicle's electronic brain. All modern cars, even those 10 or 15 years old, are controlled by a central computer called the Engine Control Unit, ECU. This computer isn't static, it's an adaptive learning system that, over thousands of miles, adjusts its parameters based on how the vehicle has been driven. This means when you buy a used car, you don't just inherit its mechanical condition. You inherit the previous owner's driving habits, now burned into the computer's memory. If the previous owner was a person who drove gently, never accelerated beyond 2,000 RPM, and spent all their time in slow urban traffic, the computer learned to be lazy. It optimized all its injection maps, ignition timing, and transmission shifts for that conservative style. The result is a vehicle that feels dull, unresponsive, with acceleration that seems to be dragging the weight of the world. This is one of the main reasons a used car can feel so different from a new one, even if it's mechanically perfect. Dealerships know this problem perfectly. Their solution is to plug in a diagnostic computer, navigate through some menus, and charge you between $200 and $400 for a basic recalibration. But there is a method you can do yourself, at no cost, in your own home, in less than 20 minutes. We're not talking about just disconnecting the battery and hoping for the best. That's what an amateur does. We are going to do a deep, complete reset that erases all the adaptive memory and forces the computer to start from scratch. The procedure is precise and must be followed exactly. First, make sure the car is completely off and the keys are out of the ignition. Open the hood and locate the battery. You will need a wrench, usually a 10mm. Disconnect the negative battery terminal first. This step is crucial for safety. Then disconnect the positive terminal. Now, with both cables completely free from the battery, comes the step most people don't know. Take the two cables, the positive and the negative, and touch them together. Hold them in contact for at least 90 seconds. I know what you're thinking. This sounds dangerous, but it's not. With the battery disconnected from the circuit, there is no risk of a short circuit. What you're doing is closing a circuit through all the vehicle's electrical systems, draining every milliamp of residual electricity stored in the capacitors and control modules. This is the magic step. This deep drain is what completely erases the computer's adaptive memory. Without this step, some of the old data will remain. After 90 full seconds, reconnect the terminals. Do it in reverse order. Positive first, then negative. Make sure they are tight. Now comes the most important part of the process, the relearning cycle. When you first start the car, the idle might be irregular for a few seconds. This is completely normal. The computer is recalibrating the idle air control valve. Don't worry. Take the car and drive it in a varied manner for the first 30 or 40 minutes. You need to give the computer a full range of data. Drive gently, accelerate moderately, and when it's safe to do so, floor the accelerator for a few seconds. Drive on the highway, drive in the city, drive uphill. The more varied the information you provide in this first session, the more complete and efficient the new performance map the computer will build. The results are immediate and dramatic. The throttle will respond more vividly. The transmission will make more decisive and precise shifts. The engine will feel more willing, more alert, as if it has woken up from a long sleep. You've just performed a digital brain transplant, erasing years of bad habits and saving yourself a considerable bill at the dealership. This is the first step toward liberating your vehicle. Trick number 2. The deep cleaning of the fuel system with a forbidden formula. Your vehicle's fuel injection system is its circulatory system. Over time, this system becomes contaminated with microscopic carbon deposits, varnish on the injector tips, moisture in the tank, and sediment that accumulates in filters and lines. These impurities slowly strangle the engine's performance, causing hesitation, power loss, and excessive fuel consumption. The conventional recommendation is to fill up with premium gasoline every now and then. This is a weak and ineffective solution that only benefits the oil companies. The octane rating of gasoline, whether it's 87, 89, or 93, has absolutely nothing to do with its cleaning power. Octane is simply a measure of resistance to detonation. If your vehicle is not a high compression or turbocharged model, using 93 octane gas when it was designed for 87 is literally burning money. You will see no benefit. The cleaning additives in pump gasoline are present in all grades, but in maintenance concentrations, not deep cleaning ones. To truly restore a dirty fuel system, you need a concentrated attack. The formula I'm going to share has 3 key ingredients, each chosen for a specific reason. First, a high concentration injector cleaner. Don't buy those cheap 50 milliliter bottles they sell at gas stations. Look for professional products containing polyethyramine, or PEA, like Techron Concentrate Plus or Redline SI1. These are industrial-grade cleaners that aggressively dissolve carbon deposits. You're going to use double the recommended dose. If the bottle says it's enough for 60 liters, use it in 30. The second ingredient is technical-grade isopropyl alcohol, not the pharmacy kind, but the 99% purity one sold in industrial chemical supply stores. This alcohol has 2 critical functions. First, it absorbs any water that may be present in the fuel tank. Water in the tank causes corrosion and irregular engine fueling. Second, the alcohol acts as a co-solvent, boosting the action of the injector cleaners. You'll add half a liter of isopropyl alcohol to the tank. The third ingredient is high-quality synthetic 2-stroke oil. This might sound strange, but let me explain the science. Modern gasoline, especially since they removed lead and reduced sulfur levels, has very poor lubricating properties. Fuel pumps and injectors operate with microscopic tolerances and depend on the gasoline itself for lubrication. A quality 2-stroke oil, added at a ratio of 200 milliliters for every 40 liters of gasoline, provides that critical lubrication. It protects the fuel pump, lubricates the injectors, and improves combustion. It also helps keep the combustion chamber clean. Here is the exact procedure. When your tank is almost empty with less than 5 liters of gasoline, first add the double dose of injector cleaner, then the half liter of isopropyl alcohol, then the 200 milliliters of 2-stroke oil. Then fill the tank completely with regular gasoline. This mixture will create an extremely potent solution that, over the next 300 kilometers, will systematically dissolve all deposits in the fuel system. During these first few tanks, you might notice the engine running slightly differently. This is normal. You are mobilizing years of accumulated grime. Some cars might experience a slightly rough idle for the first 50 kilometers. That's the dirt being removed and burned. After that first tank, repeat the procedure but with normal doses of cleaner. For the third tank, use only the 2-stroke oil. After this 3-tank treatment, your fuel system will be cleaner than it has been in years. The benefits are multiple and measurable. The engine will start more easily. The idle will be smoother and more stable. Acceleration will be more progressive, without hesitation. Fuel consumption will improve noticeably. And most importantly, you will have extended the life of expensive components like the fuel pump and injectors. All this for a fraction of what a professional injector cleaning service would cost. This is the power of real technical knowledge. Trick number 3. The hidden adjustment of tire pressure for maximum performance. Everyone thinks they know how to inflate their tires. They look at the sticker on the driver's door, see the manufacturer's recommended number, and think it's an exact science. But what they don't understand is that those numbers are calculated compromises, not absolute optimums. Manufacturers set tire pressures based on multiple factors, including ride comfort, even tread wear, basic stability, and mainly the testing conditions required to meet government regulations. These recommended pressures are designed for the lowest common denominator, the average driver in average conditions. Here's the truth that tire engineers know but marketing departments will never tell you. Your tire pressure should change based on how and where you drive. A tire is a pneumatic spring. Its internal pressure determines its contact patch with the pavement, its operating temperature, and its rolling resistance. By strategically modifying the pressure, you can completely transform your vehicle's handling and efficiency characteristics. This is racing science applied to daily driving. For highway driving, where you spend long distances at constant speeds, increasing the tire pressure by 3 to 5 psi above the manufacturer's recommendation has dramatic benefits. You reduce rolling resistance because the tire deforms less, which translates directly into better fuel economy. In real-world tests, this adjustment can improve consumption by 5 to 7%. You also reduce the tire's operating temperature, which extends its life. The steering becomes more precise and responsive because the tire has less sidewall flex. For city driving with many turns and speed changes, the strategy is different. Here, you want to maximize grip and stability. Keep the recommended pressure in the front tires but increase the rear tires by 2 psi. This rear bias creates a tendency towards understeer, which is much safer and more predictable than oversteer. Your vehicle will feel more planted in corners and more stable during hard braking. For occasional sporty driving on winding roads, this is where it gets interesting. Lower the pressure in all tires by 2 psi below the manufacturer's recommendation. This increases the contact patch with the pavement, dramatically increasing available grip. The vehicle will feel more connected to the road, with greater traction under acceleration and braking. The trade-off is that fuel consumption will increase slightly and the tires will heat up more. But for an enthusiastic driving session, the increase in handling capability is absolutely worth it. The biggest secret of all, monitor your pressures with a quality digital gauge. Don't trust the cheap gauges at gas stations. Check the pressures when the tires are cold, before driving, or at least 3 hours after. Temperature dramatically affects pressure. For every 10 degrees Celsius change in ambient temperature, your tire pressure will change by approximately 1.2 psi. This means you should adjust your pressures seasonally. Keep a simple log of your adjustments and how they affect the vehicle's behavior. After a few weeks of experimentation, you'll find the magic numbers specific to your vehicle and your driving style. You'll have unlocked a level of control over your vehicle that 90% of drivers will never experience. And all from an adjustment as simple as the air pressure in your tires. Trick number 4. The regeneration of the air intake system. Your engine's air intake system is its respiratory system. Every time the piston moves down on its intake stroke, it creates a vacuum that sucks fresh air through the filter, the ducting, the throttle valve, the intake manifold, and finally, the intake valves. This air mixes with fuel to create the controlled explosion that generates power. But here's the problem nobody tells you about. This air path becomes progressively contaminated with oils, crankcase vapors, fuel deposits, and particles that manage to get past the air filter. Over time, these contaminants form a thick, sticky film that reduces the effective diameter of the intake runners and coats the internal walls of the manifold. This restriction reduces airflow, which decreases power, reduces combustion efficiency, and creates a richer mixture that pollutes more. It's a degenerative cycle that gets worse with every mile you drive. The symptoms are subtle at first: a slight loss of power at high RPMs, gradually increasing fuel consumption, an idle that becomes less stable. By the time these symptoms are obvious, the buildup is severe. The dealership's solution is to replace components or perform a professional chemical cleaning with specialized equipment that costs between $300 and $600. But there's a method you can do yourself with basic tools and products that cost less than $50. We are going to perform a deep manual cleaning of the intake system, from the air filter to the valves. This procedure requires some basic tools and patience, but the results completely justify the effort. Start by removing the air filter box and the intake ducting that runs from it to the throttle body. On most vehicles, this just requires loosening a few clamps and disconnecting some sensors. Take pictures with your phone before disconnecting anything to remember how it all goes back. Once you have access to the throttle body, look inside. You'll probably see a black layer of carbonized oil covering the throttle plate. This grime is a combination of crankcase vapors being recirculated through the PCV system and fuel residue. Use a specific throttle body cleaner. Do not use brake cleaner or generic cleaners, which can damage the special coatings on the body. Spray generously and use a soft toothbrush to scrub the entire surface of the throttle plate, both front and back. Also, clean the inside of the body where the plate sits when closed. Use microfiber towels to dry and remove all the dissolved dirt. Repeat the process until everything is shiny and clean. Now, for the most important part, the intake manifold. On vehicles with multi-point injection, this process is relatively straightforward. Locate a large vacuum hose that goes directly to the intake manifold. The brake booster vacuum line is ideal because it's large in diameter. With the engine hot and idling, carefully disconnect this hose from the manifold. You'll hear a loud hissing sound of air being sucked in. The engine may want to stall, so you might need to partially cover the opening with your thumb to keep it running. Take a can of intake manifold cleaner. The product I recommend is one that contains acetone and alcohols, not just petroleum hydrocarbons. Insert the application straw into the vacuum hose and spray in short bursts while the engine is running. The engine is going to cough, shudder, and make strange noises. This is completely normal. You are flooding the manifold with a volatile chemical that is being immediately vaporized by the heat and sucked into the combustion chamber. This vapor aggressively dissolves carbon deposits. Continue this process using about half the can. Then, on the last pulse, spray a generous amount and immediately shut off the engine. This lets the cleaner sit in the hot manifold and on top of the intake valves where it can work on dissolving the toughest deposits. Leave the vehicle off for at least 15 minutes. After this soak time, reconnect the vacuum hose, making sure it's secure. Now start the engine. It will be hard to start and will run very poorly for the first 30 seconds. Give it a little throttle to keep it alive. A huge cloud of white smoke will start to billow from the exhaust. This smoke is all the dissolved carbon being expelled. Take the vehicle to an open area and drive it energetically. Accelerate hard several times to burn off all the residue. The smoke will continue for 5 to 10 minutes of driving. When it finally clears, what's left is a deeply cleaned intake system. The throttle will respond faster, the engine will run smoother, and the idle will be more stable. You've removed years of buildup and restored the airflow to near new specifications. This procedure should be performed every 50,000 kilometers to maintain optimal performance. Trick number 5. The secret adjustment of the automatic transmission. Modern automatic transmissions are engineering marvels, but they are programmed at the factory to prioritize smoothness above all else. Manufacturers program the transmissions so that shifts are almost imperceptible, creating a sense of refinement that pleases automotive journalists on test drives. But this smoothness Fitness comes at a cost. Slow, prolonged shifts generate excessive heat in the transmission's clutch packs. This heat accelerates the aging of the fluid and the wear of internal components. There is an adjustment that technicians know about but is rarely discussed publicly. The transmission's line pressure can be modified to create faster, firmer shifts. Faster shifts mean less slippage, less heat generation, and paradoxically a longer life for the transmission. They also dramatically improve the vehicle's response, especially during hard acceleration when the transmission needs to downshift quickly. The problem is that this adjustment normally requires specialized software and access to the transmission's computer. But there is an alternative method that works on many vehicles and that you can do with basic tools. It's called the vacuum modulator trick. On transmissions that use a vacuum modulator system to control line pressure, you can physically modify this component to increase the base pressure. The modulator is a small device connected to the transmission body that responds to engine vacuum. When it detects high load and low vacuum, it increases the pressure in the transmission for firmer shifts. The trick is to modify the modulator's internal spring so that it always provides a little more pressure. Locate the modulator. It's generally a round metal piece about the size of a golf ball, bolted to the side of the transmission with a vacuum hose connected to it. The procedure is simple but requires precision. Disconnect the vacuum hose and unscrew the modulator. Inside, you'll find a spring. What you're going to do is add 1 or 2 small washers under this spring before reassembling everything. These washers preload the spring, increasing the transmission's base pressure by about 2 to 5%. After performing this modification, the shifts will be noticeably firmer and more decisive. The transmission will downshift more aggressively when you step on the gas. Upshifts will be quicker and more direct. This adjustment doesn't harm the transmission. In fact, it protects it by reducing slippage, but it does change the character of the vehicle dramatically. It transforms it from a floating sedan into a more connected, sporty machine. If, after trying it, you decide the shifts are too harsh, simply remove 1 washer until you find the perfect balance for your taste. It's important to mention that this trick only works on transmissions with a vacuum modulator, which are common in vehicles from the 90s and early 2000s. More modern, fully computer-controlled transmissions require software reprogramming, which is beyond the scope of most owners. However, if your vehicle has this system, this simple adjustment can completely transform the transmission's personality without spending a single cent. Trick number 6. The optimization of the cooling system for extreme performance. Your engine's cooling system doesn't just prevent overheating. Its real function is to keep the engine in its optimal operating temperature range. Too cold, and the engine is inefficient, consumes more fuel, and generates more emissions. Too hot, and you risk serious damage to internal components. Manufacturers install thermostats that open at relatively low temperatures, typically between 82 and 88 degrees Celsius. This conservative temperature ensures that even in extreme conditions or with poor maintenance, the engine won't overheat. But here's what they don't tell you. Modern engines are designed to operate more efficiently at higher temperatures. Between 90 and 95 degrees Celsius is the sweet spot where combustion is most complete. The oil flows properly, and internal tolerances are at their best. Operating at this higher temperature improves fuel economy, increases power, and reduces emissions. High-performance car manufacturers install high-opening thermostats specifically for these reasons. The trick is to replace your standard thermostat with a higher temperature one, specifically one that opens at 92 degrees Celsius instead of the standard 82. This simple change raises the engine's entire operating temperature into that optimal range, but you must do it correctly and with some important precautions. First, make sure your cooling system is in perfect condition. A clean radiator, properly working fans, no leaks. A high-temp thermostat in a compromised system can cause problems. The procedure for replacing the thermostat varies by vehicle, but the principles are universal. Drain the coolant from the radiator by opening the drain valve at the bottom. Locate the thermostat housing, typically where the upper radiator hose connects to the engine. Remove the bolts holding it. Remove the old housing along with the old thermostat. Thoroughly clean the sealing surfaces. Install the new high-temperature thermostat, making sure it's oriented correctly. Use a new gasket or gasket sealant. Reassemble everything and refill the system with fresh, quality coolant. Here is the critical part. After installing the high-temperature thermostat, you need to completely purge the air from the cooling system. Trapped air will create hot pockets that can cause localized overheating. With the engine cold, open the radiator cap, start the engine, and let it warm up while monitoring the coolant level. As the thermostat opens and the coolant circulates, the level will drop. Add more coolant as needed. Tighten the cap when the level stabilizes. Drive the car normally, but carefully monitor the temperature for the first few days. The benefits of this adjustment will manifest gradually. You'll notice a slight improvement in fuel economy, typically between 2 and 4%. The engine will reach its operating temperature faster, which is especially beneficial in cold climates. The cabin heater will be more effective, and most importantly for enthusiasts, the engine will have a bit more power in the high RPM range because it's operating at its optimal design temperature. This is a perfect example of how a small change in a $20 component can have measurable positive effects on the vehicle's entire performance. Trick number 7. Advanced ignition timing for instant power. Ignition timing is one of the most critical parameters in an engine's performance. It determines exactly when the spark plug fires to initiate the combustion of the air-fuel mixture. This timing is measured in degrees of crankshaft rotation before top dead center, TDC. The engine computer controls this timing dynamically based on multiple sensors, but it works within parameters set by the manufacturer. And as always, these parameters are conservative. Manufacturers set the base ignition timing to ensure the engine runs on minimum octane fuel in high-temperature conditions and with poor maintenance. This means they leave a lot of power on the table. An engine that receives good quality fuel, is well maintained, and operates in normal conditions can benefit dramatically from a more advanced ignition timing. More advanced means the spark happens earlier, which gives the mixture more time to burn completely and generate maximum pressure just as the piston reaches TDC. The result is more power and torque throughout the RPM range. The trick is to manually advance the base ignition timing. In old engines with mechanical distributors, this was simple. You'd loosen a nut, turn the distributor a few degrees, and you were done. But in modern computer-controlled engines, the process is different. You can't just turn the distributor because everything is controlled electronically, but you can trick the computer into thinking the engine is in a different position than it actually is. The secret is in the crankshaft position sensor. This sensor tells the computer exactly where the crankshaft is in its rotation, so it can time the spark precisely. If you physically rotate this sensor a few degrees, the computer will calculate the ignition timing based on incorrect information, resulting in a net advance of the actual timing. This is a trick that professional tuners use but is rarely discussed publicly. Locate the crankshaft position sensor. It's usually mounted near the flywheel or the crankshaft gear at the lower front of the engine. You'll see it's held on with 1 or 2 bolts. Here's the exact procedure. Loosen the bolts holding the sensor but don't remove them completely. The sensor should be able to move slightly in its mounting holes. With the engine off, rotate the sensor counterclockwise about 2 millimeters. This small angular movement translates to about 3 to 4 degrees of additional ignition advance. Tighten the bolts, ensuring the sensor stays in its new position. Now comes the critical part. You need to test this adjustment carefully. Start the engine and let it warm up completely. Drive normally, paying close attention to any pinging or knocking sounds, especially under acceleration. This metallic sound is detonation, or knock, and it means the timing is too advanced for your fuel. If you hear any sign of detonation, stop immediately and move the sensor back 0.5 millimeter. Repeat this process until you find the point where you have maximum advance without any sign of detonation. When you find that sweet spot, you'll feel a noticeable difference. The engine will respond more aggressively to the throttle. You'll have more torque in the mid-range, where you spend most of your driving time. Acceleration will be stronger, and, best of all, you'll probably see a slight improvement in fuel economy because the combustion will be more efficient. You've unlocked power that was always there but was dormant due to ultra-conservative factory settings. An important warning: this adjustment only works with high-octane fuel. If your vehicle normally uses 87-octane gas, you will need to switch to 91 or 93 after advancing the timing. Higher octane fuel is more resistant to detonation, which allows for the additional advance. If you are not willing to pay for premium fuel, do not make this adjustment. Detonation caused by over-advanced timing with low-octane fuel can destroy an engine in minutes. Trick number 8. catalyst regeneration to recover lost power. The catalytic converter is one of the most misunderstood components of the exhaust system. Its function is to convert harmful exhaust gases into less harmful emissions through chemical reactions that occur in its internal honeycomb, which is coated with precious metals like platinum, palladium, and rhodium. When it's working properly, a catalyst creates minimal restriction to exhaust flow. But over time, this component can become clogged with carbon deposits, soot, and oil residue, creating a severe restriction that robs power and dramatically reduces efficiency. Symptoms of a clogged catalyst include power loss at high RPMs, excessive fuel consumption, a sulfur, rotten egg smell from the exhaust, and in severe cases, the engine may even stall after warming up. The conventional solution is to replace the catalyst, which can cost between $500 and $1,500 depending on the vehicle. But there is a method that can clean and regenerate a partially clogged catalyst without replacing it. The trick is based on understanding the catalyst's chemistry. For the catalytic reactions to occur efficiently, the catalyst needs to reach its optimal operating temperature, which is between 400 and 800 degrees Celsius. At this temperature, carbon deposits are naturally burned off. The problem is that typical city driving, with lots of idling and low load, never allows the catalyst to reach these temperatures for a sufficient amount of time. Deposits build up faster than they can be burned off. The solution is to force the catalyst to operate at maximum temperature for a prolonged period to burn off all the accumulation. This is called forced regeneration, and it's a procedure technicians perform with specialized equipment. But you can achieve the same thing with a method I call the Italian regeneration drive. In Italy, where highways don't have strict speed limits, drivers have empirically discovered that driving their vehicles at high RPMs regularly keeps the catalysts clean. Here is the exact procedure. First, make sure your fuel tank is full of high-octane gasoline. Take the vehicle to a highway where you can drive continuously and safely at moderately high speeds. For 30 consecutive minutes, keep the engine operating between 30 and 40 RPM. In most vehicles, this means driving between 100 and 120 kilometers per hour, 60-75 mph. You don't need to accelerate aggressively, just maintain a constant high load on the engine. This sustained high load operation raises the catalyst's temperature far above its normal range. The carbon deposits that have been accumulating for months begin to oxidize and burn off. After 20 minutes, you might notice a slightly metallic smell from the exhaust. This is normal and is a sign that the regeneration is occurring. Continue for the full 30 minutes. When you finish this driving session, let the engine cool down completely before shutting it off. Drive the last 5 minutes at a moderate speed to allow for a gradual cool down. The results can be dramatic. If your catalyst was partially clogged, you'll notice an immediate recovery of power. The engine will breathe more freely, especially at high RPMs. Fuel consumption will improve. The sulfur smell will disappear. You have effectively cleaned and regenerated the catalyst using only heat and chemistry. This procedure should be performed every 10,000 kilometers as preventative maintenance, especially if your driving is primarily urban and low speed. An important safety note: this procedure generates extreme temperatures in the exhaust system. After completing it, do not park the vehicle on flammable materials like dry grass or leaves. The catalyst and exhaust will be extremely hot for 30 minutes after shutting off the engine. Also, this method only works on catalysts that are partially clogged. A catalyst that is completely destroyed physically will need to be replaced. But for most cases of deposit clogging, this trick can save a fortune. Trick number 9. The total silencing of the chassis and suspension. One of the most telling signs of an aging vehicle is the noises it starts to make. Squeaks when going over bumps, creaks when turning the wheel, clunks from the suspension, groans when braking. These sounds aren't just annoying, they are symptoms that the suspension and steering components are asking for attention. Rubber bushings are drying out, metal joints need lubrication, and rubber parts are losing their elasticity. The dealership's solution is expensive. They'll tell you that you need to replace control arms, stabilizer bars, tie rod ends, and eventually that may be necessary. But the secret that experienced mechanics know is that many of these noises can be completely eliminated with strategic lubrication and preventative maintenance. You can restore the solid, quiet feel of a new vehicle without replacing a single part. The first step is a thorough inspection. Safely lift the vehicle on ramps or jack stands. Never work under a vehicle supported only by a hydraulic jack. Use safety stands. With a powerful flashlight, inspect every suspension component. Look for the rubber bushings. These are the black rubber pieces where the control arms connect to the chassis. If you see cracks or tears, they will eventually need replacement. But if they just look dry and superficially worn, they can be revitalized. The secret weapon here is silicone lubricant spray. Never use petroleum-based lubricants like common penetrating oil because these products attack and degrade rubber, causing it to swell and fail prematurely. Silicone lubricant is safe for rubber and plastics. Generously spray every suspension bushing you can reach. Especially soak the stabilizer bar bushings where the bar passes through them. These are the most common culprits for annoying squeaks. Look for grease fittings. Some vehicles, especially larger body-on-frame trucks and SUVs, still have grease fittings on the ball joints and tie rod ends. These are small nipples that allow you to inject fresh grease. This is a lost art of vehicle maintenance. You'll need a basic grease gun available at any auto parts store and a cartridge of high-quality chassis grease. Connect the gun to the fitting and pump until you see a little fresh grease start to ooze from the joint's rubber seal. This indicates you've purged the old, contaminated grease and filled the joint with fresh lubrication. Pay special attention to the ball joints. These are critical joints that connect the control arms to the wheel knuckles. Many modern ball joints are sealed for life, with no grease fittings, but on some vehicles you can add fittings by carefully drilling a small hole in the top of the ball joint housing and installing a threaded grease fitting. This process requires precision but is completely feasible for someone with basic mechanical skills. Once you've installed the fitting, you can inject grease that will protect the joint and extend its life dramatically. Don't forget the shock absorbers. Shocks have an upper seal where the rod enters the shock body. This seal can dry out and start to groan. A small amount of lithium grease applied around this seal can completely eliminate the noise. Also, inspect the rubber bump stops. These are the cushions that prevent the shock from fully compressing. If they are dry and cracked, replacing them is cheap and will make a big difference in ride quality. Perform this chassis lubrication ritual once or twice a year. The best time is during seasonal changes when the temperature is moderate. The benefits are immediate and profound. Your vehicle will feel more solid, quieter, and newer. You've given its skeleton the hydration and lubrication it needs to function properly. This simple maintenance, which almost all modern owners have forgotten, can transform a vehicle that sounds and feels old into one that feels like new. Trick number 10. The deep internal engine wash with chemical vapor. We've talked about cleaning the fuel system through the tank and the intake system from the outside. But there is one area of the engine that accumulates the hardest and most harmful carbon deposits: the top of the pistons, the combustion chambers, and the valves. In direct injection engines, where fuel no longer washes the valves, this buildup can become severe, restricting airflow, increasing compression to the point of causing detonation, and creating hot spots that interfere with proper combustion. This is the hardest problem to solve, because these areas are sealed inside the engine. There is no direct access without disassembling the engine, which is expensive and laborious. But there is an aggressive chemical method that can dissolve these deposits from within without taking anything apart. It's called a deep induction treatment, or the chemical vapor bath method. This procedure is so effective it can restore lost power and eliminate knocking issues in engines that seemed destined for costly repairs. The concept is simple, but the execution requires care. You are going to slowly introduce a specific cleaning chemical directly into the intake manifold while the engine is running. This chemical is instantly vaporized by the heat, creating a super hot vapor that flows past the valves and into the combustion chambers. This vapor aggressively dissolves carbon deposits. The critical final step is to shut off the engine engine with this chemical vapor trapped inside, allowing it to soak and work on the toughest deposits for 15 to 20 minutes. This procedure will create a massive amount of white smoke from the exhaust, so it is absolutely essential to do it in a well-ventilated area, preferably outdoors. You might want to warn your neighbors that you're not trying to signal the end of the world. Here is the exact step-by-step procedure. With the engine fully hot and running, you need to find a large vacuum line that goes directly to the intake manifold. The brake booster vacuum line is ideal. It's the thick hose that runs from the large black brake booster on the firewall to the engine's manifold. With the engine idling, carefully disconnect this hose from the manifold. You'll hear a loud hissing sound of air being sucked in. The engine will want to stall, so you'll need to partially cover the opening with your thumb to keep it running. Take your deep induction cleaner. Look for specific products designed for this purpose. Do not use generic cleaners. Insert the application tube into the vacuum hose and begin spraying in controlled bursts while the engine is running. The engine is going to protest violently. It will shudder, cough, and make strange noises. This is completely normal. You're basically choking it with volatile chemicals. Continue this controlled process until you've used about a third of the can. Then, and this is critical, on the last spray, allow the engine to suck in a large gulp of the chemical and immediately shut off the engine. This final step is what separates a superficial wash from a true deep cleaning. The liquid chemical is trapped in the hot cylinders on top of the pistons and valves, where it will work on dissolving the most stubborn deposits. Leave the vehicle off for a minimum of 20 minutes. Longer is better. During this period, don't touch anything. The chemical is doing its job. After the soak time, reconnect the vacuum hose, making sure it's fully seated. Check that everything you disconnected is back in its place. Now comes the spectacular part: start the engine. It will be extremely difficult to start and will run terribly for the first 30 seconds. Keep the accelerator pedal pressed slightly to keep it from dying. Within seconds, a massive, dense cloud of white smoke will begin to pour from the exhaust. This smoke is all the dissolved carbon being burned and expelled. It's dramatic and impressive. Immediately take the vehicle to an open area, an empty road, or a large parking lot. Drive it vigorously. You need strong acceleration, full RPM sweeps to expel all the residue. The smoke show will continue for 5 to 10 minutes of energetic driving and then gradually dissipate. When the smoke finally clears, what you're left with is an engine that has been internally cleaned like never before. The throttle response will be sharper and more direct. The idle will be smoother and more stable. Any minor engine knock you had will likely be gone. You have essentially performed a deep tissue massage on the heart of your vehicle, removing the plaque that has been clogging its arteries for years. This procedure is so effective it should be part of standard maintenance every 50,000 kilometers. So there you have it. These aren't just tips. They are a revolution in your vehicle maintenance philosophy. This is about rejecting the passive role of a simple operator and becoming an informed, empowered owner. It's about understanding that the life, performance, and reliability of your vehicle are not exclusively in the hands of the dealership's service department. They are in yours. By adopting this forbidden knowledge, you are taking control, saving yourself a fortune, and forging a deeper connection with your machine. You now possess the secrets to making your used or pre-owned vehicle run better and last longer than anyone thought possible. If you've made it this far, you are clearly one of us. Someone who isn't afraid to get their hands dirty and unlock their vehicle's true potential. If you've tried any of these tricks, or if you have a forbidden secret of your own, I want to hear it. Leave it in the comment section below, because I read everyone. And if you want to continue this journey of automotive empowerment and learn more secrets the industry doesn't want you to know, make sure you are subscribed with that notification bell fully activated. There is much more to discover, and our next video could save you from a 4-figure repair bill you don't need to pay. Drive smart, drive safe, and never stop learning.